Welcome to the class, students. Okay, student, you see here the definition of differential equation is an equation involving one dependent variable, one or more independent variable, derivatives of dependent variable with respect to independent variable, right? So we can call it as differential equation. Now the same thing I wrote over here. Here differential equations are actually two types. One is ordinary differential equation. I'll write like this, Nana, because you do the speed. Ordinary differential equation, right? I'll write like this: ordinary differential equation. Now partial differential equation, right? Ordinary differential equation, partial differential equation. Now ordinary differential equation and partial differential equation. So ordinary differential equation means one dependent variable, one independent variable is there. For example, if I write like this, dy by dx is equal to something x by y. Here you see y is dependent, x is independent. Derivatives of dependent variable with respect to independent variable is there, and here, right, one derivatives of dependent variable with respect to independent variable is also there. So this type of equation is known as what? Ordinary differential equation, right? Partial differential equation means here x dou u by dou x plus y dou u by dou y is equal to nu I wrote. What is the meaning of this? A differential equation in which one dependent, here dependent variable is u, independent variables are what? X and y, right? Two independent variables are there, one dependent variable is there. That's why we can call it as, this type of equation is known as what? Partial differential equation, right? Now the question is, okay, now you see here ordinary differential equation and partial differential equation. We are going to study about ordinary differential equation. Now I would like to divide ordinary differential equation in two parts. Okay, part 1 and part 2. In part 1 I would like to discuss order and degree, right? Degree and formation of differential equation, right? These are the 3 points I am going to discuss in part 1. This is part 1. Now you see here part 2. What is mean by part 2? Part 2 is very clear, sir. Solution of differential equation. Part 2 means here solution of differential equation. Solution of differential equation, we people are going to discuss up to mains. There are 7 levels are there. You see here, these are the types are there, ways of solving the differential equation. One is variable separable. VS means variable separable. Now second one is reducible to variable separable. Reducible to variable separable. Now third one is homogeneous. Homogeneous equation. In homogeneous again 2 is there. 2 types are there. Sometimes we will take y is equal to vx, or other time x is equal to vy also we will take. I'll explain when it is. Now homogeneous 2 ways. And the next one is non-homogeneous. Non-homogeneous. Non-homogeneous is also 2. One is having, I'll consider like this, Nana, having common term. Having common term. Second one is not having common term. Not having common term, right? Fifth one is linear differential equation. Here also we are going to discuss 2 types. Next, sixth one is reducible to linear differential equation. Reducible to linear differential equation, you can say 6th. And the 7th one is inspection method. What is that? Inspection. 7th one is inspection method, you can say, right? Till here if you are perfect, up mains level questions you can do. Not only this, okay, not only these 7, 8th one is, you see here, orthogonal trajectories. Orthogonal trajectories. 9th one, okay, exact differential equation. In exact differential equation we have what? 4 different types. All those 4 we will discuss. Then 10th one is soluble for P. 11th one is soluble for X. 12th one is soluble for Y. Right, soluble for Y. And 13th one is application of differential equation. In application of differential equation, we have what again? Physics relatedly, mathematical relatedly. Okay, some time problems are there. We'll discuss here 2 to 3 different types of problems are there. We'll discuss. But mainly, these are all important for advanced. Till mains means up to inspection only mains one. Okay, these all things are there. We are going to discuss in differential equation one by one. Now, first let us start with order, degree and formation. Part 1 will discuss. So now in part 1, see here, order. Okay, order, I'll explain here, roughly I'll explain here. Order and degree together, sir. Order and degree I am going to explain. Right, what is mean by order means, suppose d square y by dx square plus 2 dy by dx. See here, y is equal to 0. This is the differential equation is there. You see guys, what I am saying, that you know very well that y is dependent variable, x is independent variable, and derivatives of dependent variable with respect to independent variable is there. So order means how many times you have differentiated. See here, the more number of times you have differentiated dependent variable with respect to independent variable. Okay, independent variable. Okay, the more number of times you differentiated dependent variable with respect to independent variable, how many number of times, that gives us the order. What is the order of this one means, here we differentiated 2 times. That's why we can say that order is 2. We can say that order is 2. Okay, order is 2. So in this one, you please select with the example I am explaining. Rather than writing the definition, I am explaining with the example. So here more number of times we differentiated comparatively this one. Therefore the order is what? 2. Now here this one is also we differentiated variable, dependent variable with respect to independent variable 1 time, but this one, whatever the term here, degree, to decide degree, you see here, you select the term in which more number of times you differentiated, okay, dependent variable with respect to independent variable. The degree of this one is called, what is the degree here? 1. So degree of this term is, this degree of this one is known as degree of the differential equation. The degree is 1. Hope so that you understood, right, the definition. Rather than writing the definition, I wrote like this. But here some important points are there. I would like to write few examples. You see here, x dy by dx whole cube is plus 7y is equal to 0. Right, one problem. Second problem is like this, dy by dx whole to the power of 1 by 2 plus d square y by dx whole to the power of 2 it is, and whole to the power of 1 by 3 and whole to the power of 1 by 4 is equal to 0 is there. And the third one is, sir, you see here, d cube y by dx cube whole to the power of 2 minus 3 dy by dx whole to the power of 5, okay, minus e to the power of x is equal to 4. Third example I have taken. Another fourth example I would like to take, d square y by dx, okay, d square y by dx square plus dy by dx, okay, dy by dx whole cube whole to the power of, I would like to take few examples here to get clarity. Okay, you should get a clarity here, y. Now the question is, we got it like this. Next one you see, fifth one is, okay, this is the one of the example here. Fifth one is like this, dy by dx, sine of dy by dx is equal to x plus dy by dx is there, sir. Or another sixth one also I would like to take, d square y by dx square plus 2 dy by dx y plus y is equal to logarithm of dy by dx is there. For this degree and, see here, for this order and degree, right, while finding degree you are supposed to avoid the radicals. Now you see here, we don't have any radical over here, so straight away we can say that order is 1 What is the degree of this? 3 you can say. Right, 3 you can say. These are what? See Nana, 1 by 4, 1 by 3, these are all. Right, what it is, you please remember what it is means. These are what? Radicals, we can say that. First of all, you have to remove the radicals. Degree, of course, order you can say that directly. Okay, order is what? 2. To find degree, you are supposed to remove the radicals here. How? You see a 1 by 4 you can remove. So what we will get here? 1 by 2 plus 2 into d square y by dx square whole to the power of 5. Right? And whole to the power of 1 by 3 is also there. That is equal to 0. Right? Equal to 0 is there. 1 by 2 is there. Here 1 by 3 is there. If you raise the power both the side, taking that side on 6. Right? And 6, I think it is good. That is what? dy by dx. Okay, whole cube will get. Taking that side, after taking that side we are doing now, minus 2 is there, minus 2 to the power of 6 it is, and this 2 is outside, the 2 is outside, whereas here d square y by dx square whole to the power of 5 is there, and after cancelling this 2 we have. Now this 5 and 2, this is what? 10. Right, 10 we have what? We can avoid like this. So now degree we can say. What is the degree of this equation means? Okay, the degree of the equation means, you see here after taking this one that side, what I did here, after taking this one that side, I raised both the side, the power is 6. 6 means here we'll get like this. Here also 6 means 6 is available for this, and 6 is multiplied by here 2, 10 we are getting. Now you see here we'll get like this. What is the order means? We already told that clearly like this. What about the degree means? The degree, highest degree of this one is what? 10. Yeah, you can write 10 over here. Now come down to the next one. For this equation, what is the order? Order is what? 3. The degree is what? 2. Whereas here you cannot say. Here also you have to first of all simplify. What is that? d square y by dx square plus dy by dx whole cube. Right, and straight away take that side. 6y to the power of 5 by 6 you can write. Nothing will happen here. There is no dy by dx term. So you can write like this. Chalega. So now you see here, this is the order is 2. Order is 2. What is the degree? 1 we can say. Whereas here only dy by dx is there. Order is 1. And in this case is order is what? 2. But degree is undefined. Why? We cannot make free from the sign. We cannot make free from logarithm here. In both the case, degree is undefined. Degree is what? Undefined. Hope so that with this 6th example, please remember we cannot make free from dy by dx, we cannot make free from sin x, and in this case we cannot make free from log x. So that's why we can say that these are all, okay, these are all best examples. You will get command in the degree and order. Now as I told you that after this one, okay, after this one, formation of differential equation I said. Right, formation of differential equation. Yeah, I would like to take two different examples for formation. See here, for formation of differential equation means I would like to take a e to the power of x, b to the power of minus x I'll take, where a and b are arbitrary constants. Let us say this is the example. Okay, this is the example he has given. Formation of differential equation, one equation, okay, where a, b are what? Arbitrary constant. So depends on arbitrary constant, you please differentiate the equation, given equation that many number of times, okay, depends on this arbitrary constant. Here how many are there? 2. So we have to differentiate with respect to x, nana. So you will get dy by dx, a to the power of x minus b to the power of minus x you will get. One time you differentiated, second time also we have to differentiate here. That is what? dy by d square y by dx square is equal to a to the power of x, b to the power of minus x you can say. Now you see there are two ways are there to evaluate. Luckily we got it here like this. We can replace this by what? Y. So actually we have what? 3 equations. Actually when you differentiated 3 equations. So directly by evaluating you will get it here like this. The other way is also there. What is that? You can go for determinant also. What you are supposed to write, sir? You see here e to the power of x, here also what? E to the power of x, here also e to the power of x you have to write, and next minus e to the power of minus x here, Okay, sorry, only e to the power of minus x, minus e to the power of minus x, here e to the power of minus x, and taking that side minus y dy by dx. Remember, dy by dx will treat as y1, d square y by dx square will treat as y2. Right, so now minus y1 minus y2 equal to 0. See here, nothing will happen. You can evaluate, determine d to the power of x, e to the power of minus x, and minus 1 I am taking common. 1 1 1, 1 minus 1 1, y y1 y2 is equal to 0. Now you see, while expanding, you know very well that minus y2 minus y1 minus here y2 minus y1, right, plus y into 1 plus 1 is equal to 0. So 2y2 is equal to 2y, that is nothing but y2 is equal to y. That only we got it now. Like this we can do. What best example we selected here, right? And I would like to take one more example. See here, that example is this, Nana. For example, here some formulas are also there. Please learn how to learn. I'll give you the formulas also for this. A to the power of x plus b to the power of minus x plus c e to the power of 5x is there. And whereas here a, b, c are arbitrary constants. Second example I am taking here for formation of differential equation. How many number of times you have to differentiate? 3 times, because these are all 3. So you see, y1 differentiate with respect to x. So a e to the power of x, here minus b to the power of minus x, c5 e to the power of 5x. Yes, no problem. Once again, differentiate with respect to x. You see here a e to the power of x plus b to the power of minus x plus 25c e to the power of 5x you can write. Now once again, y3 differentiate with respect to x. 3 are there, that's why we are differentiating 3 times. b to the power of minus x minus 125, not minus 125, plus 125c e to the power of 5x. You see, the procedure how to do means the same story. E to the power of x, 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 e to the power of minus x, minus e to the power of minus x, e to the power of minus x, minus e to the power of minus x, and here e to the power of 5x, 5 e to the power of 5x, right, and 25 e to the power of 5x, and 125 e to the power of 5x. Next one, minus y, minus y1, minus y2, minus y3. We have what like this. Yeah, what to do here? After taking common, take this one and make these 3 are zeros and expand. You will get the answer. While expanding, you will get the answer. But one more method is there. What to do? The direct formula is there, Nana. What is that formula? Suppose if you has given like this, y is equal to a to the power of alpha x, b to the power of beta x, c to the power of gamma x is there, then d cube y by dx cube minus alpha plus beta plus gamma and d square y by dx square plus alpha beta, beta gamma, gamma alpha into dy by dx plus alpha beta gamma y is equal to 0. This is the formula, sir, a special formula which I want to give you. Yeah, you can understood clearly. So now with this formula directly you can write dy by d cube y by alpha beta gamma. What is that alpha? 1 minus 1 plus 5. Okay, sir, d square y by dx square here. Okay, plus first one minus 1, then minus 5 plus 5. Okay, dy by dx. Why? AB, BC, CA, sir. That's why we are getting like this. And the last one is plus, first one plus, minus, plus, next one is minus. Okay, here minus, plus, this is minus, Nana, sorry, minus here. So alpha beta gamma, 1 multiplied by this one, 1 into minus 1 into 5, and y is equal to 0. This is your answer. Please remember this type of formulas are there in our material also. You can find anywhere, you will get it here. 2-3 formulas are there. Please learn either this method or this method. Okay, right. Now students, you see here some theoretical questions also they may ask in formation. One problem I'll do. I don't want to waste my time. Okay, I don't want to waste your time also. What is the question here? You see, Nana, the differential equation. The differential equation. See here, question is, third question here I am doing. The differential equation of the family of curves or family of circles, we'll say circles, family of circles touching y-axis at origin. One example, I am taking one example, nothing else there. So now you see, only one example I am taking here, based on theoretically they may ask you like this. Solution is like this, Nana. What he said, this is x-axis, this is y-axis, origin. He said that a circle is going to touch y-axis at origin. Definitely that center should lie on a x-axis. Therefore, this become what? Radius. So answer is x minus a whole square plus y square is equal to a square. This is the equation of circle, not exactly answer for the differential equation. No sir, first of all, we are writing here how many arbitrary constants are there, etc. we have to decide. So now x square plus y square minus 2ax equal to 0. How many arbitrary constants? Only one arbitrary constant. So differentiate how many times? One time. This is your equation 1. Differentiate with respect to x, Nana. So 2x plus 2y dy by dx minus 2a is equal to 0, or a is equal to x plus y1 will get. y1 you know very well that substitute a in 1. So x square plus y square minus 2x into x plus y1 equal to 0. Or finally y square minus x square minus 2x dy by dx equal to 0. This is your answer, like this. Okay, now you see, we did first part of differential equation. In first part of differential equation we did till here. Okay, now we are going to discuss about solution of differential equation. In solution of differential equation, the first one is variable separable, right? I would like to take 2-3. My intention is very clear. First I would like to introduce all the methods, all 13. Okay, all 12 methods I will introduce. Later onwards, we'll do some previous NIT, IIT, some good questions on differential equation. Let me introduce the method first of all. If you thoroughly come across these all methods, you won't get any problem while solving differential equation. That's why I'm one by one I'm introducing now. You see here, variable separable. I would like to take one example here. Simple examples I'll take so that you can feel happy. So y dy plus y plus 1 dx equal to 0. Yeah, there is a differential equation. He has given like this. Do one thing. Variable separable means all x's are one side and dx one side. Dy by dx and y terms are other time. You have to write. For that, x plus 1 y dy is equal to y plus 1 dx with minus. Or else you can write like this: y divided by y plus 1 dy plus dx divided by e to the power of x. Okay, like this we got it. I am habituated to write x first time, Nana. So after writing this, integrate. So after integrating, you see here, I am taking e to the power of x common. Right, e to the power of x, if I take common, 1 plus e to the power of minus x dx I'll get. And here integral of y plus 1 minus 1 y plus 1 dy and integral 0 you can write. Furtherly, e to the power of minus x. Okay, derivative of this one is minus. I'll write like this: dx. See, integral of minus e to the power of minus x by 1 plus e to the power of minus x. And whereas here 1 minus y plus 1 dy integral 0 is there. Just you see here, Nana. Derivative of this one is there or not? Yes, is there. That's the reason f dash x by f of x means logarithm of mod 1 plus e to the power of minus x. And here y, integral 1 means y, integral of this one means logarithm of y plus 1. Yeah, it depends on option. You can select this constant, whether you want to write c or whether you want to write. Okay, here I'm taking log c to tell you in a better way. So y is equal to, you see here, logarithm of c into, right, c into y plus 1. Another one is 1 plus e to the power of minus x also, you will get it here. Or finally, e to the power of y is equal to cy plus 1 plus e to the power of minus x. Like this we got it. This is called variable separable method. That means solving differential equation by separating all x's and y's along with dx and dy, we are evaluating like this. I'll take one more example. right? I'll take one more example. That example is, you see here, Nana, simple examples I'll take to get a command on it. So x square e to the power of minus y plus e to the power of x minus y is there, right? What we have to do here, okay, of course dy by dx is there, minus y you take common, x square plus e to the power of x is there, fine. Now you separate it, you will get e to the power of y dy is equal to x square plus e to the power of x dx will get integral of x square plus e to the power of x dx, right, minus e to the power of y dy, right, integral 0. Yeah, you can write x cube by 3 e to the power of x, integral of this one is e to the power of y. You want to write, you can write c, stop here itself, no problem. Yeah, I have taken one more example here. So sir, one example I want to take trigonometric related, 2 examples I have taken, one more example I would like to take on variable separable. This time I would like to go for trigonometry, that is tan y secant square x dx plus tan x secant square y dy is like this. Simple example, you have to understood clearly, that is my intention. I'll introduce later onwards, after completing all the method, definitely I'll introduce, you see that. So now dy tan y secant square x dx minus tan x secant square y dy, I'm taking that side, right, I got it like this. Now you see here secant square x by tan x dx plus, okay, whereas here secant square y by tan y, after rearranging we will get like this. Now you integrate, right, after integrating, derivative of this one is here now, that's why directly log tan x you can write, derivative of this one is here, you can write log tan y, and you can say log c also, chalega, tan x here, tan y, and this is what log c you will get. Now tan x tan y is equal to c is your answer. Right, now you see, we would like to take one more example. 4 examples I would like to give. Here dy by dx is equal to root over 1 minus y square divided by root over 1 minus x square. One more example. Yeah, segregation. What is that? Dy by dx 1 minus y square. Here dx by under root 1 minus x square. Simple. 1 by under root of 1 minus x square dx, and dy divided by root 1 minus y square. Here 0. So directly we can write sin inverse x. This is sin inverse y, your wish, right, c or sin inverse c also you can write, nothing will happen. So variable separable is completed, sir, right. So in the next class, we would like to discuss, yeah, before going to complete this class, see here, I would like to introduce reducible to, right, variable separable, reducible to variable separable. I want to give 2 examples here. You see here, Nana, dy by dx, suppose here why I use the word reducible to, you see here with this example it is very clear, you cannot separate this one. So at that time we are taking a help of substitution here, x plus y is equal to t I am taking, and differentiating, after differentiating we'll get here dt by dx, everything we are going to convert in terms of dt by dx. So dt by dx minus 1 is equal to sin t plus cos t. I have taken one example here for reducible to variable separable. I am trying to reduce this equation into variable separable. Yes, yeah, you see here, yes, we got it finally. So dx, okay, integral dx, okay, minus 1 dt by, or 1 plus sin t plus cos t in an integral 0. Rearranging, after rearranging I got it here. Now this is what x, no need to worry. Whereas here in this case tan t by 2 you have to take some p na. Again substitution is there, it is integration method you have learned, right, tan t by 2, that is dt is equal to 2 dp divided by 1 plus p square. It is very, I think you people are aware of this one, so that's why I am writing directly. So now 1 divided by 1 plus 2p by 1 plus p square, here 1 minus p square by 1 plus p square into 2 dp by 1 plus p square integral 0. So x, after simplifying, finally you will get 1 plus p only, right, dp, and like this 0. So x is equal to logarithm of 1 plus p, you want you can write here log c, and you can write like this also, x is equal to log c into 1 plus p you can write, So here logarithm of c as usual, p means you know very well, tan t by 2, t means x plus y by 2 also you can write. This is your answer. One problem we did it. One more problem we will do Nana on this, where it's reducible to variable separable. Hope so that you understood clearly. One more problem we would like to do. So the problem is this Nana. Suppose if I take like this, dy by dx is equal to something, tan square x plus y is there. What to do here? X plus y is equal to t only. 1 plus dy by dx is equal to dt by dx. Now dt by dx minus 1 is equal to tan square t. So dt by dx is equal to 1 plus tan square t means secant square t will get. Or else you can write like this, dt by secant square t is equal to dx, or integral of dx, integral of cos square. Cos square means 1 plus cos 2t by 2 dt is equal to 0. Here it is integral, sir. X, so you can write 1 by 2 I'll write outside, t, and integration of cos 2t means sin 2t by 2 you will get, and here it is you can write c by 4 also chalega. So now this is what, 4x minus 2t minus sin 2t is equal to c. Now you substitute the value of t, you will get the answer, right? I have given 2 examples for this. One more example. Okay, not only always xy, sometime you may have like this also, sir. dy by dx is equal to 4x plus 9y. It's a familiar one for you people, right? So now 4x plus 9y plus 1 is equal to t you take. Directly you can take, and 4 plus 9 dy by dx. This is 4, sir. 9 dy by dx plus 0. This is what, dt by dx. Yeah, you can write, what is that? 1 by 9 here. dt by dx minus 4, replace this one, is equal to, this is what, t square. You see, dt by dx minus 4 is equal to 3t whole square you can write, or else dt divided by 3t whole square minus plus 4 is equal to dx, or else integral dx after integrating this 1 by 9 you write outside is better. So t square plus 2 by 3 whole square, right, dt integral 0. Finally x 1 by 9, this is 1 by 2a tan inverse, right, t by 2 by 3, and you can write c. Your wish, according to the option you can change. Okay guys, okay sir, today we discussed up to variable separable and reducible to variable separable. In the next class we'll discuss homogeneous. Bye.